Welcome all of you again. Welcome all of you on my YouTube channel. So today we are going to discuss the MPLS Part 2, and inside that we are going to discuss the few part of MPLS and the tables as well as we will do the configurations side by side. Okay, simultaneously we will check the configurations as well inside the MPLS. Okay, so basically, guys, inside this area, the MPLS is gonna be work inside the global service provider one. Okay, and the BGP is also running inside of it, and OSPF as well on these areas on inside the these routers. If I'll show you the configuration of that, let me just the OSPF IP OSPF interface brief. So you will see that OSPF is running, that is process ID 1. Okay, we will discuss what is that. Basically, this is the some TCP MD5 digest mismatch error. We are getting that, but don't worry, we will just make it clear. Okay, so inside this, the multiple protocols are working. I'll show you the BGP as well. Show run by section BGP. So you will see the BGP is also running. That is a address family VPN v4, as well as your address family IPv4 and IPv6 as well. Sorry, IPv4. Okay. So we will use the BGP is already running, OSPF is already running. Just a few steps we have the problem inside that. So we will also discuss what can be the problem inside the MPLS. That is, we can find it out in our network. Okay, side by side we will do the configuration of MPLS, and then we will discuss basically before doing your troubleshooting steps. We will do the configuration of MPLS. Then you will have the some ideas about how it works, how we can configure, and then we will move to the configuration, the troubleshooting part of MPLS over here. Okay, that can be like how you can get the problem, what kind of problem that you can face it inside the MPLS. So we will discuss that as well. Great. So let's discuss without wasting the time of MPLS. Let me open the whiteboard. So in a previous video, if you have ever watched it, so in the previous video we have discussed that is how MPLS works, what kind of traditional routing we have. Okay, like the traditional routing, if I'm talk about, that would be process switching, fast switching, and self switching. Okay, process switching, fast switching, and self switching. Okay, self means Cisco Express forwarding. Okay, so this the all the MPLS is gonna be work on this self switching. Okay, so what are the process which is we have? Then we have the MPLS header. After that we have discussed MPLS header, and inside the MPLS header, what kind of content it can carry. So that information we have already discussed in the previous video. If you want to watch, so I will just mention that previous video link in the description box of this video as well. So you can go and watch the basics information about the MPLS. Okay. Then let's discuss then after that the few bits of the labels, types of labels inside that. Okay, like all the kind of, see, all the MPLS is totally gonna be depend upon the labels. So what kind of MPLS labels which is we have? So first label, if I'm talk about, that is we called VPN label. Then we have MPLS, what I'm writing it, MPLS LDP label, label distribution protocol, that is we called. And this is our all the kind of protocols which is we are going to use, that is all depend upon LDP only. Then we have MPLS TE table. Okay, so uh, traffic engineering, which is we called it traffic engineering, Mpls, traffic engineering. Okay, so like where your BGP is gonna be work, quality of service. Okay, BGP, multicasting. Okay, so these kind of protocols are gonna be work inside the traffic engineering label, and this is also comes with your wireless part, wireless you can say that, or voice part. Okay, where your all the traffic is gonna be like that travel, like whenever you make a call or whenever you schedule some telephonic interviews or some video conference. So that's totally depend upon these kind of things, voice and wireless and all the things. Okay, so like we have pop 3, this kind of this kind of protocols is gonna be work inside of that. Okay, so if I talk about the label number, how the label is gonna be exchanged in that. So the label number is locally significant. What is that? Locally significant. Locally significant, that means route router will store on 16-bit information regarding this. Who will store? Router will store that information. Okay, info. Fine. So how these labels are gonna be basically check it, how the router is gonna be check that. So it depends upon the two protocols, that is we called LDP and TDP. Okay, the LDP, which is we called label distribution protocol. What is that? Label distribution protocol. And this is what? This is our open standard. And one more thing, TDP, that is we have tag distribution protocol. Okay, this is our Cisco proprietary. Okay, that means the LDP, which is we use like in all network we use LDP protocol, because of we don't have any information that beside of this the ISP, which company laptop or which company devices we are using beside of that. Okay, suppose that this is your internet service provider and we will use the MPLS over here, right? So this MPL, we don't have any information like we are using the Cisco devices or any kind of other company devices. So that's why we will always prefer the LDP protocol to use the things inside of that. Okay. Now let's discuss basically some tables as well. Okay. Let me just write it down the few points as well
Jay,
over here. Yes.
can you tell LDP TDP?
Yes. Yes. Why
Yeah.
not? That's why I'm
So
on it. Okay.
where we use these LDP and TDP on these C router
Yes, on
or
CE
inside the
and
code?
PE, see, whatever the MPLS we are running on the devices, either we have customer edge or provider edge. So over there between that, we will use the LDP and TDP protocol. Basically, what is that? Whatever the routers or devices which is we have, right? Whatever the router or the devices we have over here. So what they will do, they will just exchange their information using labels. Using labels. Okay, so what is this labels information they will exchange? They will exchanging using the some protocol. Okay, so what will be the protocol which is we can use? That is LDP and TDP protocol. We have two types of protocol, that is TDP and LDP. So the for the label we will always use we will always prefer label distribution protocol, not the tag distribution protocol. Okay, we don't have any information about this, so that's why we can use the LDP over there. And we will also use the TDP as well inside the, whenever you will send any information using any tagged information which is coming from your BGP or any kind of other protocols, okay, such as quality of service or any kind of others. So by default, let me just tell you about this. By default, LDP is running on Cisco devices. What is that? LDP is running on all Cisco devices. So whenever you will configure the MPLS, so by default you will find it out the LDP is running on that. Then second point which is we have, that is we it share the two kind of information, that is local table and remote table. What is that? A remote table. So inside the local table, it shares own information. That means it shares own table. And inside the remote table, it received by the or you can say that uh, res- by the neighbor, by the neighbor. So whatever the information you will receive, that is coming by the neighbor router. Okay. Now one more point I can note it down over there. That is the route will share only local label always. The router basically, the MPLS router share only local label always. Local label always. What is that? That is about their own table. Local table, that means about their own table. If you have the four routers over there, would be like connected like this, and they will exchange their own information about the labels, like what is the IP, what is the port number, right? So this kind of information they will share with the neighbor. Okay. And the remote label, which is this router, whatever the this neighbor router which is we have, if this router is getting any label which is coming from the neighbor, it will consider it this label as a remote, right? Let me take a simple example for you. Let me just, can I erase all? Now let's suppose we are connecting inside the team inside this meeting. Okay. Now whenever the first class we had, if you remember, like we start with the introduction. What? We start with the introduction. So like we have in this meeting we have 12 participants inside of that. The some participants name are would be Anoop, right? Just like Anoop. We do have Prince, right? We do have Raj, Sunil, whatever the name guys you have. Okay. So what we do, we just share with the everyone. Okay. So what I'm sharing my name, my details, right? And my the certification and knowledges and experience. Okay. So this is what, this is our local information. This is what, this is our local information, which is I know that. Okay. Because of I know what is my name, what kind of experience I have, what kind of where I am from, what I have done, we know very well. That means this is about local information for me. But if I'm sharing it with this information with the others, so that information will called for the, suppose that I'm sharing this information, my information, to the prince. So prince will understand this is the remote label. Correct? That means whatever the information I'm getting it from my neighbor. That means this is the remote label information which is I'm getting it. So that means between the routers, if they exchange their information, so for their own information, that is we call local. And if it is getting any information with the neighbor or any others, so that information which is we called remote label information. Correct? Sorry. So let's discuss. Let me take a scenario of the 2 3 routers over here. Let's suppose we have router 1, then we have router number 2. Similarly, we have router number 3. Similarly, we have router number 4. So these routers having some IP address. Let's suppose this have the IP address which is would be 12.1.1.0 slash 24 network. This have 23.1.1.0 slash 24 network. This have 34.1.1.0 slash 24 network. Correct? Now we do have the some prefix as well over here. What is that? This is 10.1.1.0 slash 24, and it also have the some prefix would be like 40.1.1.0 slash 24 network. Let's suppose so it's here their LIB, labeled information base. What it will share? LIB, that is label information base. So what is that? That would be we know very well that is where we are connected and what is my IP address. So we know that what is my IP address, that is local IP address we have to mention, right? So the table would be created would be like this have the IP which is 10.1.1.0 slash 24 network, and this is receiving the some IP which is coming from the neighbor. That would be what? That would be 12 network, 23 network, 34 network, and 40 network. So what can be 12.1.1.2, this network, okay, 1.2, you will get it, okay, and this is you will get the 23 network as well, and you will get the 34 network and 40 network as well. So these network is what? These network are a remote. What is that? A remote label. Let me just. This network are what? This is our remote label. And this is what? This is our local information. LFIB, local forwarding information base. Okay. Now, then after that, it's here. The every router will maintain this kind of table with everyone. Every router having the same table. Let's suppose this router number 2. This is for router number 1. Now, let's suppose for the router number 2, which is we have. So router number 2 having the two local, that is 23 and 12.1.1.2 and 23.1.1.1. This is our what? This is local. And what will be the remote? The remote would be your 12.1.1.1, 23.1.1.2, and 34 network. The whole network I'm just writing it over here. And then we have 40 network as well as 10 network as well. Okay, so don't forget that network as well, 40.1.1.0 slash 24, and then we have 10.1. So this is our remote label. This is our remote label information. So this will be work like that, and it will, if anyone have to share any information, so always they will just share this information with the everyone else using these kind of things. Okay, did you get my point in that? So that we can move to the configuration part of this mpls now.
Yes, yes.
Okay.
Okay. Jay,
Yes.
instead of giving task to us, can you show the configuration yourself? Do you have access to GNS and all?
uh, right now I don't have any access of the gns, but for sure, I'll do one thing. I'll just make the configuration by myself. Whatever the
Yeah.
task I have given you, I'll just make it by myself and I'll show you from tomorrow. But for today, whatever
So,
I'm, yes,
no,
yes.
no, the topology you have given is too complex that we cannot understand through this. Can you make a fresh one by using simple 2, 3 routers?
Okay, like you're talking about this.
Yes, you can take this lab as well. So we can do that. Otherwise, the complexities it has, we cannot understand the things.
Okay,
Uh, at
the
least me, I don't know about the others. I want MPLS to be should be understandable to me
yeah,
in
yeah,
simple words.
definitely, definitely. So let me just,
I don't know how experienced others are with MPLS, but I'm not. I'm a fresher, so I want to understand it well.
no problem. We'll take the new scenario for that. Okay, let me just turn on
Please,
the,
thank you.
but
Or even if you have any plain simple lab, that would also work because the complexity of the existing
I
lab is
can
that we
understand.
cannot understand new things.
I can understand. That's what I'm taking it. I'm taking a new lab 43,192. Let me just 43,192. Or 192. Check it, is it working or not? Previously it was not working for me. Okay, great. Correct. So let me take the another scenario. Let me stop selected, delete selected. Let me add the some notes over here. Okay. And what I'm going to take the scenario, let me just, I will also just give it to you. Add a node. So it's not the firewall. L3, we have to take a router. This is our router one. Okay. So save it. Same as doing a right click node. Select the IOL. This is router number 2. Save that. Um, I'm going to make this the scenario. Okay.
Uh,
Yes, yes. Tell me.
the,
Any doubt?
if we require the cloud, so how can we? I think
For here, I don't have
in
any cloud
particular diagram,
access. We don't have
if
any.
for it's EVNG, not cloud.
Yeah, that's not a cloud. That's Eve.
Okay,
We have to add, the particular image, and then we have to, that is lots of work we have to do. Then we can add the cloud. We have the
okay.
option. We can add it, but for here, we are not able to do that. I'm going to take the same scenario, right? Which is this. Okay. So we'll do one thing. Quickly, we will configure the BGP, OSPF, and then MPLS. Okay. That's gonna be very quick configuration. So please be available with your free mind. 3, 4.
So why are you adding OSPF here?
Because
Can't we
of,
do this lab without it?
yeah, we can do that. But why I'm adding this? just because of if we need to configure the mpls,
To make the reachability.
yeah, to make the reachability as well as to like if we have to configure the mpls on a multiple ports, so how we can do that? So this ospf will help you out. Okay, because of we don't know that how many kind of routes are working inside your internal area, right? But we know that if the ospf are working, so that would be we can configure it the mpls over ospf. Now let me make the connectivity. Ethernet, fine. And from here, Ethernet, fine. Let me just make it. Actually, it takes a little bit time, but don't worry, it will just work properly. Because of we don't want any kind of other things inside this, but yeah, if it's all working, so that would be great. Let me start selected. Let the routers come up. One, two, three, four, five, six. All done. Click. Let me just take the access. Let me delete that. It takes time because of that power on self test is gonna be work on every devices. Whenever you will turn on any device, that power on self test are gonna be work pure, which is we called it post, if you remember. I think I did not turn off all devices from here. Yeah, let me just turn it off because of it takes lots of RAM, right? I'll show you. It's taking 50% utilization for the memory. Taking the 14 GB in use. Come on. That is why, guys, I will prefer always the high configuration devices. If you are planning to, if anyone is wants to perform the good activities on the networking, so I will always prefer you the high end devices. Okay, let's configure quickly the IP addresses on these routers. Everyone's are up. Let me quickly take the access of every routers. It is a notification we are getting.
Yeah. Yes, actually, your voice is not coming so
Properly, it's not coming.
definitely you are on mute, I think.
No, I'm
Yes, yeah,
audible.
you are on.
Am I audible now?
Yes, yeah, you are audible now.
What I'm taking the every device's access so that we can quickly configure the IP address and then OSPF, right? So
Which
yeah,
one is C and P?
all the kind
Can you
of,
also mark?
see where your EBGP is gonna be work. I'll do one thing. I'll take the few routers as well. So that would be your, the provider edge. Okay, but for here, let me just quickly configure. So 10 network. Then we have 20, 30, 40, and 50 networks. So this is how we are going to configure. So interface Ethernet 0 slash IP address, that is 10.1.1.1.255.255.255.0. Okay, then do no shutdown. And for here we have to use what network? 20 network. So interface Ethernet 0 slash 1 IP address. This is 20.1.1.1 space 255.255.255.0, and do no shutdown. And here we have 30 and here we have 40 networks. Okay, so let me configure the 40 network 0 slash 2 IP address. So that would be 40.1.1.1.1.0. Correct. Now let me configure IP addresses on the router number 2. Let me do no shutdown first of all on this interface. Let me show you IP interface brief. So 10 network running on this interface, 20 network is running on this interface, 40 network is running on this interface. Correct? Let me take the access of router number 2, and same as we have to do the configuration of IP. So interface Ethernet 0 slash 0 IP address. So here is 10.1.1.2. Correct? Dot 0, and do no shutdown. And then from here, we have which network? We have uh, 10, 20, and 30. So interface Ethernet 0 slash 1 IP address. So that would be 30.1.1.1, and do no shutdown. Let's configure the 10, 20, 30, 40, and 50 network over here. Okay.
Okay, it should be 30.112.
No, for the dot two, we are going to use on the edge these devices. Only 1.1.1.1.1 we are going to use on these
Okay,
interfaces.
okay.
Okay, that would be great to understand, right?
Yes, yes.
Hmm. So for here we have to use no, sorry, for here we have to use the 50 network. So interface Ethernet 0 slash 2 IP address 50.1.1.1 255.255.0. Correct. So all the configurations are done on this. Let me show you IP interface brief. So 10.2 on this interface, 30.1 on this interface, 50.1 on this interface. So let's configure the quickly configuration of your first of all 20 network on this interface. Okay, so interface Ethernet 0 slash 0 IP address, which would be 20.1.1.2. Okay, and do no shutdown. Correct. Let's configure 30 network on the router number 4. So interface Ethernet 0 slash 0 IP address, which would be 30.1.2, and do no shutdown. Okay, on the router number 5, let's do configuration of 40 network. Interface Ethernet 0 slash 0 IP address 40.1.1.2. On the 6th number router, that is 50.2. So interface Ethernet 0 slash 0 IP address, which would be 50.1.1.2. 255.255.255. Do no shutdown. Okay, so all the configurations are done of the IP address. Let me do the right on the all the every devices. so that every configurations are safe regarding the IP. Okay, do right. Router number 4, router number 5, and then router number 6, which is we have already run in it. Do show IP interface brief. So if I'll show you, so here is the IP. Okay, so all the IP configurations are done. Let's configure quickly the configuration of BGP over here, and as well as OSPF as well. Correct. So let's configure first of all the OSPF and advertise the OSPF, all the kind of things inside the area 0. Every interfaces is going to participate inside the area 0. So what are the interfaces running on that? Interface range Ethernet 0/02 uh, 02, right? IP OSPF 100 and then area 0. Do show. Okay, sorry for that. I have to run a command. First of all, router OSPF 100. That's all. If I'll show you interface brief, so these are the interfaces is participating inside the area 0. So let's quickly do the configuration on the router number 2 of the OSPF. Automatically it will assign, that router ID. So I'm not going to configure any manual router ID on that. So automatically it will take the highest router ID over here. Okay, simple. First of all, router OSPF 100. Do exit interface range Ethernet 0/022. Okay, IP OSPF 100 and then which area? Area 0. So neighborship will come up with the router number 1 because of we have already configured it. Let me check it. Okay, the neighborship comes. Now let's configure the OSPF on router number 5. Let me do one thing. Let me open the notepad because of all the times I have to, you know, router OSPF 100 do exit interface Ethernet 0/0 and then IP OSPF 100 and then area 0. Is it all the command which is we are going to use on every routers? Let's do that quickly on this router number 3. Sorry, I think I have done some mistake. Come on. No, that's fine. Okay, and one more thing you can add it over here. Do right and end. Okay, now so let's configure on the router number 4. On router number 5, simple, do the right click. We don't have to type again and again, right? So all the configurations are done regarding OSPF on every router. If I'll show you routing table on the router number 1, so you'll get it over there, IP route. So you're getting it as a correctly and OSPF, that is O means that your OSPF route. O means your OSPF route. You can see the AD value of that 110, correct? Now, the only one thing which is we have to do, that would be your BGP configuration. If you want, so we can do that. Otherwise, we can directly configure the MPLS over here. What do you want, guys?
No BGP. Or at least, if you want, at least point-to-point BGP only, not the complex one. Just make the neighborship between C and P. So
Okay.
R3, R5, R6, R4 would be the CE routers here.
Yes, all the routers right now is the CE customer edge. Okay.
Not all. R3, R4, R5, R6 only, right?
Yes, these are.
And so we can make a BGP neighborship between R3 and R1 like this. R1 with R3 and R5 and R2, R4 and R6.
Um.
Is it possible? I don't know if it is possible here.
Yes, it's possible. It's possible. Right. First of all, what we can do, uh, we can configure the BGP IBGP protocol. We can take it. Okay, IBGP configuration. So all the kind of configuration would be same as on the every router. Okay, I think that would be great. If you want, so we
Why
can do
IBGP?
that.
Mm, Why
Uh,
IBGP? We
See, I
can't
can
use EBGP again.
I can do one thing. I can just configure the IBGP in between that. Okay,
Mm-hmm.
and for here we can
Yeah,
take the
BGP.
EBGP. Correct.
Yeah,
So BGP AS number 200, AS number 200, AS number 200, and AS number 200, AS number 100, and AS number 100 on that. So between that, your IBGP is gonna be work, and between that, your EBGP is gonna be work. That would be great. Understand the topic?
yes, but
Let me. Bit of complicate, right? Where's my pen? Come on. Let me just. It's a bit of tough to understand, but no worries. I'll just explain. So this is gonna be participate BGP AS number. Come on, what I'm
can
saying.
we keep different AS number on the customized
Yeah,
routers at least?
any kind of things we can take it. But for your understanding purpose, I'm going to make it easy. Otherwise, I can take it any of that.
We take different one.
Okay. So for here and on this both the router, we are going to use 100. We can take it. Is it fine?
Yeah, IBGP is fine.
Okay. Then for router number three, we can take AS number.
65,534.
Not that. We will take
Take any.
30,
Yeah,
40, 50, and 60. That would be, that's great,
EBGP.
right?
Yeah.
So let's do the configuration quickly.
There are four different AS numbers.
Yes, this is for different AS number.
Okay. 13, 15, 14, 16.
Let's make the connection first of the IBGP protocol. Okay, and let me just make it aside. Okay, correctly. So let's configure the IBGP first of all between the router number 1 and 2. And yes, so how we can do that? Router BGP 100, and we are not going to use the BGP router ID, just only neighbor. Who's the neighbor? This IP address. So this is what? Um, 10 dot 1 dot 1 dot 2, and then remote AS. What is the remote AS? That is 100. Correct. Let's do the configuration on the router number 2, and so router BGP 100 neighbor. So who is the neighbor? 10.1.1.1, and then remote AS, that is 100. BGP neighborship will come up. Takes time. Okay. So BGP neighborship comes up with that. Now let's do the configuration of BGP with this AS as well. Okay. So first of all, on the router number 2, let's do the configuration of eBGP. So how we can do that? Router BGP 100, and then we have to give the neighbor, and then which IP address it is. It's 1020 IP address, right? So that is 20.1.1.2, and then remote AS. So which is the remote AS? That is 30 network. AS number 30, correct? And for here we have to use other 50 years for this, which network? uh, 10, 20, 30, and over here the 40 network is running, correct? So we can use 40.2. Okay, so we have just only two neighbors, right? Let me show you once again the configuration of that. This is running on the 15. Let me. So this is the configuration of BGP. This is for IBGP. This is for eBGP. But just only we have to take the configuration of eBGP on this router. I haven't done it yet. Okay. So let's configure the same thing on the router number 2 as well. That is
Can you
router.
show the urban config once again?
Yeah, sure. Of the BGP.
Yes. What was that? Okay. 40.
Is
That's fine.
it correct? Check the IP address and remote AS as well. Is it correct?
Yeah. Yeah.
Fine. So let's configure the eBGP with this. So the IP address is running, that is 10 network over here, 20 network over here, and 30 network over here. Okay. So give neighbor, that is 30.1.1.2. Because of all the IP addresses would be 2.2, right? And the remote AS would be 40, correct? And then for
Yes.
this, yes, in it out, do you have?
51 okay.
Correct. Do show
Yes.
run by section on.
Sort.
Okay, so here is the configuration of BGP. Let's just only what we have to do, configuration of BGP on these routers. Let's first of all do the configuration of router number 3, which would be the router BGP what 30. Then we have to give the neighbor. So who is the neighbor? That is this network. That means 20.1.1.1, correct? And then remote AS. So who is the remote AS? That is this network. Just wait for a few minutes. The neighborship will come up. Come on. Yeah. Got it?
Yes.
Now let's do the configuration of router number 5. 345. Okay.
Four.
Configure terminal router BGP 1 what 50, right? Because of our router number 5. So AS number is running, which is 50. Correct? Now what we have to do, neighbor. Who is the neighbor? 10, 20, 30, and 40 network is running. Correct? And then remote AS. Remote AS would be 100. Wait for a minute. Let the neighborship comes up. Correct? So let's do the configuration of here on the router number 4. So yeah, the network is running. Router, first of all, configure the BGP. That is 40 AS number. And then neighbor. So who's the neighbor? 10, 20, and 30 network is running, right? So 30.1.1.1. And then remote AS. What is that? 100. Let the neighborship comes up. Come on. Okay. Let's do the same thing on the last router. Now, on the router number 6, router BGP what 60. Then neighbor. Who is the neighbor? 50.1.1.1.1. Correct? And the remote AS would be 100. Let the neighborship comes up. Fine, guys.
Jay, can you show the neighbor statement configuration of R3?
Is it?
Okay. And now R2. You have not configured for R1.
Here is that.
You have, okay.
Come on.
10.1.1.1. Remote is 100. Fine.
Correct. Any
Yep.
doubt regarding this? As of now, no. If you don't, so we can proceed for the MPLS now. Say yes, no, guys. Something.
Yeah, Jay, till now it is understandable.
Thank God. Okay, fine. Correct. Okay. So, for the OSPF, if I'm talk about, So suppose that if I want to enable the mpls over on all interfaces, because of we know that we need the mpls on every interfaces, on this interface, this this and that, whatever this we have. Okay, we always need the mpls configuration on every ports. So how we can do, because of all the routing protocols are working over here, that would be your bgp and what, your ospf as well, if you want. So uh, we can check after configuration the lfib table, we can also check that. And we can also we can configure the ldp protocol as well. Okay, and if you want to manually configure the mpls on a particular interface, so how we can enable the mpls manually on a particular interface of the router, and what would be the command for that? Let me show you first of all that command to run a particular ldp over on that particular interface. Okay, so how we can do that? Interface ethernet 0/0. Now simply we have to type mpls ip, that's all. Simple, we don't have to do anything. Now if you want to configure any ldp, so we have,
Jay,
yes.
you're going fast. You're going fast. So you said just type MPLS IP. So what exactly it is doing? What it exactly does to enable the MPLS?
See, um, if you want to enable the mpls, like suppose that we have to share some information using some labeled information. Okay, because of we
Mm-hmm.
know that we don't have any kind of that check the authority to check the how much that routes are coming inside the mpls, where it is coming
Mm-hmm.
from. So these kind of things, where you will get that particular local fib table and fib table, right? And this things, this the mpls comes with your ldp protocol, which is comes with your ldp protocol. So what we are going to configure, mpls ldp, and then we can configure it for the igp related parameters as well. We can go for the igp parameter related, otherwise we can go for the ldp discovery parameters. Okay, for the
And this so
yes,
this R1 is like acting as a PE for us, right?
yes,
So this is a PE configuration, MPLS IP and then MPLS LDP, etc.
yes. See,
Okay.
we have to configure the mpls, doesn't matter we have provider edge or customer edge. If we need to do
Mm-hmm.
that, then we must have to do on every router. So why we don't
Okay.
configure it with the any kind of protocol, right? So just like if you have the bgp, so we can configure the mpls bgp command as well after going the output of mpls bgp, and then it comes with the bgp neighborship.
So MPLS IP, we given the interface, so MPLS is enabled, right?
Yes,
Just
that is
MPLS IP
MPLS
only.
enable on this interface. If you
Yeah.
manually want to enable the MPLS on a particular interface, so then we can enable it. If you want the MPLS enabled on a particular, whatever the interfaces are advertised inside the particular routing protocol, if you want in a one command that all the mpls is gonna be work on every interfaces on the devices on the router, then you have the another option that as well, for that as well. Okay,
Oh,
MPLS IP is fine. So now we will do MPLS. Uh, what else it is? MPLS.
see, we have two types of configuration regarding mpls. Let me just explain it first. First configuration for the interface basis. Okay, so for the interface basis, we have to go where, we have to go on interface, that would be interface ethernet 0/0. Then we have to run a command that is
MPLS IP.
mpls ip. So then your your configuration of mpls will be done using the interface if you want to enable the mpls on the global basis. Second one is
Global means it will be applied on all the interfaces of the device.
yes. So whatever the interface is, suppose that this interface, or this interface, if you have, if you want to enable the all the interfaces MPLS on all the interfaces, so how you can do that? The some protocols are working on this device, such as let's take off OSPF. So what we have to do, we have to go inside the router OSPF, whatever the process which is running. Then we have to run a command that would be MPLS LDP because of we are going to use LDP protocols. By default, why we are not using the LDP over here? Because of the LDP is already pre-configured. All the Cisco devices having the LDP protocol by default enabled. Okay. Then what we have to do, we have to enable it for the LDP, that is MPLS LDP auto config. Okay. So that is the command. So whatever
So
the
globally,
see,
so
yes,
just globally,
for the global basis.
globally, globally, we are enabled only simple the command global. What we can put this command on globally enable the MPLS.
Everything we will check it. Okay, for the whatever the command we have in the mbls, every command we will check that. Okay, just for your understanding purpose. Okay.
So if we put the global basis command like this one, mpls ldp auto under the OSPF process ID, so
Mhm.
then there is no need to put it in under the interface.
No, there's no need because of what we have done. We have advertised the interfaces, all the interfaces in the some areas of the OSPF, right? We know that the OSPF is running that is 100 process, and these interfaces has been advertised in some OSPF areas. So what we need to do, we do
We
if
will
you want
advertise.
to reduce the time, if you want to reduce the time of the MPLS configuration, then what you can do, directly go on that particular router as the protocol as number, that would be this, and then you can run this command. So automatically all the kind of the mpls ldp protocol is enabled on every interfaces which is advertised inside the ospf 100 process number. Got my point? Means
Yes.
suppose that if I have 100 50 ports, suppose that. So for using this command, we have to take the access of every interfaces, and then we have to run a command that is mpls ip, correct? But suppose that, let's suppose there is some requirement, certain requirement which is from the our client basis, that is the our client is want, that is I want every interfaces which is running inside the ospf or inside the particular protocol, those interfaces is going to participate, starting participating inside the mpls. So in this case what we can do, we can go on the particular particular protocol, and then we can run this command. Then automatically mpls will be enabled on particular protocol basis, right?
Correct.
Got my point? Can we implement this command?
Yeah.
Correct. Now we have enabled this command over here, but let me disable that as well. No mpls ip, I'm not going to enable it just for here. So what I'm going to enable, that would be simple. I am going to inside the ospf router ospf 100, then I'm going to run a command, that is, let me show you which command we can run. So let's suppose router OSPF 100, and then MPLS LDP autoconfig. Simple.
What
Can
about advertising the interfaces?
all the kind of interfaces is going to participate whenever, see, right now we know that I have enabled, just like, see, just like OSPF. Suppose, let's suppose I have enabled the OSPF on this interface, but I did not enable the OSPF on this interface. So then how the neighborship comes up? The neighborship will not come. Then what we have to do? For the neighborship purpose, we have to enable the MPLS from the both the side. Then the neighborship will come up. How, guys? Just simple. With if you are using any protocol such as LDP, MPLS is also kind of protocol, guys. Try to understand. MPLS is a kind of also protocol. So what does the protocol meaning, and what is the use of that particular any protocol? If you have to enable the protocol, then you have to enable the protocol between the two devices, right? So MPLS is also having the same thing. If you want to enable the MPLS, then you have to enable the MPLS between the two sources or the two devices. But I have enabled the MPLS only and only on the router number 3. So let's enable the MPLS on the router number 1 as well, inside the same OSPF. Inside the same OSPF, what we have used, this configuration. Let me do exit.
But if you see in the production, we use BGP, right, for the CEP connectivity. In this case,
For this case, MPL, the BGP. See,
and we will also use the BGP between P and C neighborship.
one more thing. Let me tell you.
We had a discussion.
Yes, let me tell you one more thing. Let's suppose I'm sending some routes from here. That would be 40 network, 40.40.40.1 slash, let's suppose 24 network. Okay, so I'm sending this route inside this area, which is coming by the you can advertise in the OSPF as well and BGP as well. But which one will make the best? Always the lower
BGP.
AD value. Always lower AD value will be preferred.
Yeah.
Okay. If you have ever learned the BGP path attributes, then it will go for that. Okay. If it have to choose the BGP, then it have to go for the path attribute. So it will check the all the path attributes, that all the kind of path attributes are coming inside this or not. If it is coming, that's fine. Otherwise, it will go for the OSPF then. So for the EBGP, because of I'm using suppose that over here EBGP. So for the EBGP, it comes with this 20 AD value. But over here, the IBGP is running. So what will happen? This convert inside the 200. Now, whenever the prefix will receive on these two routers coming via the 200 the 200 AD value, but the OSPF is also running over here. Then what it will do? It will do compare with the OSPF and IBGP protocol. Whatever the AD value which is we have, then it will make the OSPF as a best. So whatever it have to send it, then it will just make it. They will just prefer that route using your OSPF because of it is receiving the lower AD value inside this area. So always it will prefer the lower AD value which is we have. Got it? That is why this is we called customer edge. That is why, guys, what is the reason? That is the reason. Got my point? If you
No, this
enable,
is a provider edge, right?
yeah, this is provider edge. Okay,
Hmm.
but this provider is connected with the EBGP protocol, which is running with the 20 AD value.
Mm-hmm.
Correct? This is running with
Mm-hmm.
the 20 AD value. They know that we are whatever we are sending the route, which is comes with the 20 AD value. But over here, the provider edge always understand the lower AD value which is we have, that is OSPF. If OSPF or EIGRP are running in that, so always it will
Mm-hmm.
go for the lower AD value because of IGP having the AD value which is
Hmm.
200.
But what I have heard is in the OSP, in the core of the MPLS, it is only a OSPF.
Yes, correct.
BGP is not there, so they will tweak the settings to prefer that or use only that protocol.
Yes. So for here we have one more thing, that is MPLS VPN. Correct. So MPLS
Mm-hmm.
VPN, where we connect, where we create tunnels.
GRE tunnels.
Yes. Okay.
And I think this is the mostly used product of MPLS, right? Everyone use MPLS VPN.
Yes, that is the main reason. Okay,
Mm.
if I'll show you the configuration of lab as well, so you will find it out the same thing.
Yeah. So okay, go ahead with the configuration where we want to see the exact the
Okay.
BGP. Take CEP as a BGP, please. No, not the OSPF.
Um, so we have to advertise them manually. We don't have any other option.
Yeah, just put the network 000. It will advertise all in one go.
So what should we do? Like, what you want over here? Tell me that once again.
We want PEC to be BGP,
Okay. And what
not the
about
OSPF.
MPLS? Not the BGP. What about the MPLS? What do you want?
MPLS simply it will come up, right? MPLS will come up.
Yes. Let me enable it for the. Let me check it for the BGP
We can try for one at
process.
least.
Let me try. Let me try. I think I have to check it out. Basically, that this version support that command or not. Okay, because of it depends.
Just
Router.
I can correlate
Just
actually
hold
with
on
the
a
product.
second. Router BGP that is 30 and MPLS. MPLS. No, that's not working. MPLS. Let me check it. Uh, uh, uh,
LDP.
label. Let me label protocol. LDP, this is how you can enable the LDP, right? After enabling the LDP, what we have to do, we have to define the mode as well. MPLS LDP, label mode. See, this is for the VRF. So if you have the VRFs, then we can go for that. Okay,
Hmm.
got it? If you don't
Yeah.
have any VRF, so we don't have any other option for the BGP and would be like that. But let me check it the previous configuration.
We can make a VRF quickly.
Yes. Uh, 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 no, I don't think so. We have that. Not an issue. Let me check it for the interface basis. MPLS BGP we have, yes. BGP and then forwarding, correct? Because of this interface is going to participate inside the BGP. So interface Ethernet 0/1. MPLS BGP. What? Forwarding. But before that, we have to enable the MPLS LDP, right? So MPLS protocol, MPLS label protocol, sorry, label protocol LDP. That's not gonna be work, as I know that. That is why what we have to do, we have to, we have to enable it for the global basis. So what we can do, we have the another option, interface Ethernet 0/0 simple type MPLS IP, right? And for the router number 3, MPLS IP. Then the membership will come up. See, got it? Now you can configure it.
Uh,
Yeah.
no, can you, have you configured that MPLS label protocol LDP command as well on the R3?
Yes, I have configured. Let me show you. Run file
It's a
section MPLS.
global
Let me tell you. Let me tell you.
MPLS
This is the command which is we used for the MPLS. Got it? Got it?
Yeah, three commands.
Yeah. If you wanted to enable it for the OSPF, so we can enable it over here on the router number 1. Want it? How you can do that?
Mm,
Let me tell you.
mhm.
Let me tell you. Router OSPF 100, because of OSPF is running on that. Simple, run a command mpls ldp autoconfig. Let's do the router number 2 because of we did not configure anything on the
Wait,
router
wait,
number.
wait, wait.
Yes, yes. Tell me.
Can you again show the R1 config? You have, yeah. What, what you have put in
Just
MPLS
after going inside the OSPF
LTP auto config.
autoconfig.
What is this?
Got it? The same kind of things I'm going to use it on the. Let me just. So I'm going to use it the same thing. MPLS label protocol LDP on the router number 2. So where we have to go? We have to go on that particular router OSPF. So router OSPF 100 MPLS LDP auto config. Neighborship will come up with this neighbor 40. It's not coming up with the 10 network? Okay, because of that OS the this is our provider edge router, right? That is why it is coming the neighborship with the 40 network because of I have configured manually. I have configured the MPLS IP on this. If you have ever seen that on the router number 1 comes with the 50 network. Where is the 50 network? Here is that because of I have configured the MPLS on the router number 2. So it comes with this. This is quite critically quite tough to understand this kind of things, but yes, we must have to do that.
No, no. So what happened? It is wrong something or
No, it's not wrong. What we have done, we run the MPLS on the router number 2, right? And then the
Mhm.
neighborship will come up with this and this and what I'm saying that which is coming on the router number 1. Let me just run a few command after running the all the kind of configuration, which is that uh, I'm running this command that would be on every devices I'm going to run router OSPF 100. And one more thing, before this we are going to run a command that is in a global mode. Yeah,
The MPLS LDP auto config.
just let me write it down, then you will understand. Okay, router config mpls um, label protocol ldp. Then where we have to go, we have to run a router ospf 100. Then we have run a command mpls. Let me write it down. mpls ldp.
Auto config.
Yes,
So it is on all routers or just the
all router I'm going to configure it, correct, on every router. And then we will, yeah, we will troubleshoot the network. We will see how the ldp is going to bind, how the forwarding is going to maintain in the tables. Okay, how the ceph table is going to maintain for the particular prefix as well.
router OSPF? Auto OSPF 100 MPLS auto. Okay.
Okay,
Mm-hmm.
and we will take the example of CCIE lab as well. We will we will open the CCIE lab and then I will just.
No, no, no. I don't want to see that complex lab.
Okay, not an issue. Fine. Let me just quickly run the command. Whatever
Mhm.
the configuration we have done doesn't matter. MPLS label protocol LDP. Okay. Then router OSPF 100 MPLS LDP autoconfig.
So I never saw this in the LDP neighborship in the enterprise routers. Can we
No.
do? Can we check it the neighborship by
Yes,
command
yes, yes,
our
yes.
own?
Definitely, we can check it. We will discuss. Okay, don't worry. We'll check everything. Everything we will check. Don't worry about that. So, what was that? Let me just copy the command from here and let me paste it inside the notepad. That was. Then after that, we have router OSPF 100. Then we have LDP autoconfig. Correct. Then we have to do right and then end. Control A, Control C. Let's paste it on every devices. On the router number 2 as well. On the router number 3 as well. On the router number 4 as well. Let me just correct. Router number 5 as well. The neighborship is coming up. I'll show you as well. Router number 5 and then last
And
router.
they, because
Yes.
they are using the Mpls LTP autoconfig, is there anything required to advertise the interfaces in the OSPF
Mm,
manually?
no. But yes, yes. Before doing anything, we must have to make sure all the interfaces has been already advertised in OSPF. Then the membership will come up.
Yeah, that's right.
Okay.
So
Now let's troubleshoot. See, the neighborship comes up with the 50 and 30 network on the router number 2, which is 30 network here and 50 network here. Correct. Then router number 1, it comes with the 40 network. So where is that? 10, 20, 30, and this is 40 network. The previously we have done the 40 the 20 network. Let me show you. This is 50. This is 20 network. Okay, LDP neighbor. You can see. Now let me show you on the router number 3. So the LDP neighborship comes up with the 40 network. Got it? Now all the kind of things are done. So let's troubleshoot. Let's check the particular MPLS LDP parameters first of all. Okay. So what are the parameters? It is checking that we will discuss. Do show MPLS. What was that? LDP parameters. Okay. So we are going to check the parameters like what is the back of, how much time it is going to check it, is it any loop is going to detect or not. So if it is, if you get any loop detection, so you will get the output as well over here. Let me just make it zoom. So LDP features, so what are the features it is providing? Basic features, IP over MPLS, which is we can run the command, for the interface basis. For the TDP, we are not using IGP sync, so all the kind of IGP protocol is synced with that as well. Auto configuration, and then TCP MD5 failover, a rollover. Okay, and what is the MPLS protocol which is it running? That is version 1. Now we have the hold down timer, session hold timer, that is 180 second. We do have the keep alive interval timer, that is 60 second. Okay, we have discovery hello hold down timer, that is 15 second. We do have interval timer, that is 5 second. Discovery tagged hello hold down timer, 90 second. We do have interval timer, that is 10 second. Then we have downstream on demand max hop count, that is 255. Means maximumly max the 250 hop away it can reach. Okay. If you want to write it down the timers, because of see these timers are very important guys. You can write it down. No one will tell you these kind of about the timers and all. Just write it down these things first.
Can you help us to understand what are those like session hold time?
See, this is about your, basically we are using the two kind of things on the router number one, for the provider edge and for the customer edge basis. For the both the things we are using. So this, the session hold down timer. That means whenever you just make the neighborship, LDP neighborship. So how much timer it just make your, the session basically between with this neighbor. So that is the whole time timer for the session. Keep alive, that means after every 60 second it sends the LDP message to, get update to your neighbor that your neighbor is still available with the LDP neighborship or not. Okay. Then we have what? Then we have discovery hello hold down timer. That means, uh, discovery message, which is it goes off, means it wait for the hold down timer whenever you have to send the any hold, the hello message after every 5 second. Okay. So it wait for the 50 second whenever if, any routing protocol neighborship goes down, then it will wait for the 15 second. Then if it is not getting up, then it will wait for, 15 second, and then it will break the neighborship. Then we have what? Discovery tagged hello message. And this one having the hold down timer, that is 90 second, and then interval. That means your discovery tagged hello message will send after every 10 second, and it will, if the neighborship goes down, it will wait for the 90 second, then the neighborship will broken. Okay. So that is the uses of every timers inside that MPLS. I hope you understand. It's a quite tough to understand, but what should we do, guys? This is new for you, but if you have, if you have to work on that, then you will understand this kind of thing. Because of, once I just studied this MPLS, I was also shocked. Because of no one will see you, no one will explain this kind of things to you, and you will never find it out anything. MPLS is not a small protocol. This is very big. This is very big. Even I can't understand. Like, if you want to go for the particular certification, so BGP and MPLS does have this kind of things. You can go for the particular certification. Okay.
So the engineers who work in the core of the MPLS, they have to know everything, right?
Yes.
But the person who are dealing only the customer routers, they hardly
They must
know
have to know
or
about that, what we did the
need to know.
process. They must have to know about what we did the process. Like, if you get any problem in that, so how you can resolve, where you will get the problem, and where the problem can be exist, right? But you must have to know about the, basically where the back of session is gonna to end and all the things. But you must have to know about that. Okay. Any of you have
Um,
doubt regarding this command? You can write it down, that command as well.
so MPLS LDP parameters.
Yes. We have to check the parameters, like what kind of parameters the if you are using LDP, MPLS, LDP protocol. So what can be the parameters which is it can use? So these are the parameters. What are that? These are the features and LDP parameters. Okay. Now let's check. Let me show you the another command. MPLS, LDP binding. So we can check that which network has been binded, and which one is remote and which one is local binded. See, are you getting that? the local information and remote information over here. Get the point? See, this is the network we have, guys. 10 network, we have
3.16.
20 network, we have 30 network, we have 40 network, and we have.
I think just let we make a one lab from ourselves so that we can understand these parameters better.
I will also assign you, okay? But
Mm-hmm.
don't worry about that.
We are doing the same thing. We are doing the same thing what you have described in your current lab. Like doing this.
Okay, not an issue.
This is better.
But
This will be better.
whatever the troubleshooting
Consistency,
command,
where are you doing the?
No, no, no. I'm just taking this four or five routers what just so I have to configure the OSP flavor, then BGP
You're
flavor,
trying to
then the
configure the same lab. Okay.
yeah, yeah, yeah. Try to same kind of frequency. Try to
you
store.
can do it later as well. I'm recording the session. I will also upload the YouTube as well for the
Mm-hmm.
your knowledge
Later, later.
purposes and all. Okay, I'll share you the link as well, so you can follow that. But just for now, please be focus everything from here, because of you will get the you know the videos as well after that. But if you get distract from here, so you will totally distract from the particular upcoming practicals and all, which is it's coming, right? But if you have ever seen this very carefully and very understandable, so you will never face any problem. Okay, so that you can know about like where can be the problem can be exist, what can be the troubleshooting commands which is we can use. Got it?
Yeah, yeah.
Now we have lib entry, local information base entry. For which network? For this network. And for the which local binding which is we have, the label number it decided, that is 17. What are that? These are the uh, link state, remote state, whatever that is it? Okay, LSR, link state, locally or remotely, you can say that. Okay, so these are the IP addresses of the remotely which is it is getting. Okay, if it
And
is, if
IMP null. Yeah, sorry.
this is implicit null label. Okay, when it will share whenever you are not directly connected with this neighbor. So right now I am router number 1 and I'm getting this network entry, lib entry. So always whatever the lib entry you have, you will get the same implicit null label with the same lib entry. For the every network you will see, for the 40 network over here, we have local information base entry. For which network? For this network. So for this network, this will never make any kind of the labeled information and all the things. Always it will make implicit null because of its own information. What is that? Its own information. So how it goes? It will not goes. Local information base, right? You will see over here the 30 network. So 30 network is not the 30 network here, but yes, this kind of things we must have to check it for everything. But
Why
some
60 is not here?
uh,
Router R6.
R6, where is the 60 network is running? Come on, you are making me fool. We just
But
run
it's
a
on the
10.
R6, no?
We have run just only network that is 10, 20, 30, and 40. Sorry, for not 30, 30, 40, 50, not the 60 network.
So what is on the R6?
R
Um,
R6 is
R16
having the 50
latest number
network.
16 is there.
R6 is having the 50 network. Let me show you the diagram.
Yes, yes.
Come on.
Okay.
Don't be confused, guys, okay? And don't make me
R1,
that
R2
as well.
is 10. Then
I think R,
R3.
R6, how do you put the 16? I think 100,
Yes, not
40, 50, 60,
this
and
is
30.
this is
uh,
50, this is 40, this is 30, this is 20, and this is 10.
Which one is 30? R5.
R4 is 30. Here is R5 having the 40, and R6 having the 50.
J 40, 30 is R1 between
Six.
R1 R3.
Let me write it down. Otherwise, you will get confused.
Yes.
So for here, what is that?
10.
Correct? For here?
Yes. I think this is 30.
No, 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 no. I'll show you that IP address as well. I have
Okay.
totally remember. 30 is here. Here is 40. And here is 50. If you want, I will show you that particular, the IP address. Let me show you that. Otherwise, you will get confused. Okay, got it. See,
Yes, yes.
on router number two.
Yes, it is clear.
Come on, IP. See, this is two network 30.1 on this Ethernet, this network for this 50 network. Got it? I hope you understand. You can
Yes.
try the same thing on your home as well. Okay, and let me just make the another command. Let me show you the another command for the troubleshooting purpose. Okay, so what are that? We have run the two command, that is mpls ldp binding and mpls show mpls ldp parameters. Then we have show ldp forwarding label. Okay, if you want to check the label, the forwarding label, so how you can check it. So do show, come on, mpls forwarding label. Okay, so you will see the pop label and the multiple labels which is we have for which network, whatever the network which is we have, and label number you will get it over there. Okay, who is the next hop means where it is coming from, the label which is coming from this here, and for which network, that is 30 network and 50 network. The 30 is running here and 50 is running here, which is this label is receiving using this interface, that is ethernet 0/0. Correct? And what are the network which is 50 network and 30 network, and which is receiving via this IP address of this network ethernet 0/0. Got it? And you get the IP address as well, the next hop IP. Where it is coming from? It is coming from, who is the next hop address? This is the next hop address. You will get it over here. 10.1.1.2. Is it? Right now I'm on the router number one. So who is the next hop, or who is the neighbor IP? This is 10.1.1.2. Guys, say yes, no, something.
Yeah.
And here is the different routes, which is 30 and 50. So we are getting the 30 and 50 route as a pop level, because of this is not directly connected. So always the directly connected network you will not get as a pop label, you will get as a mpls label or local label. Okay, but for the remote label, or you can say that pop label, you will always get as a pop label or the remote label. Okay, if I'll show you on the router number two, that is forwarding table. Let me show you on the router number two. um, Let me go on that. See, the pop label, which is 20 and 40 network, which is coming via the 10 network. 20 network is running here and 40 network is running here, and which is coming via this next, which is this interface IP address. Got it? Receiving via which interface? Ethernet 0/0. Got the point?
Yes, yes.
And the for the directly connected, you will not get it, but I think you will get the on the router number three or four. Let me check it for the same thing. On MPLS label. What is that? No, no. MPLS forwarding label, right? Forwarding label. So yeah. So for the router number four, right now I'm on the router number four. So this is getting as a label or the pop label, which is coming via this 10 network. 10 network. See, the 10 network means one hop away. Okay, one hop away. Always you will get is as a one hop away. If I'll show you on the router number six, so you will get the 10 network inside the pop label. Okay, and for the different network, which is 20 network, this one you are getting as a some outgoing. Okay, and for the 40 network you are also getting it. For the 50 network you are also getting one hop away. That means between this 50 network we have one mediator device, that is router number 2, same as on the router number 1. So this one and this one is our pop level, but the another, which is 20 network and 40 network, would be our the some labeled information. You will get it. Got it? Which is coming via Ethernet
Mm-hmm.
Yeah,
0/0.
but the outgoing interface which it is taking, it is 0 by 0.
Where is that?
Right side in
Yeah,
the table.
that's this interface. Outgoing
But
interface means if it is have to receive or send in something, so which interface it will use? It will always use the same interface which is it have.
And like
Guys,
floppy.
try
And
to
floppy is
understand.
also same.
Yeah, because of all the things are same means it is using everything for the every level. It is using only one interface because of it have just only one interface, and it is sending the all labeled information using this interface only. So that is why you are getting outgoing interface would be this Ethernet 0/0.
yeah, yeah, that is fine. But in the previous router, I think in router 2 or router 1, it is showing the
It will show
interfaces
different.
of different remote AS.
So
We can see.
where is that remote? Yes, right now I'm on the router number 1.
No,
Where is
no,
that?
no.
So it will be different. It depends on the device through which it is connected,
No,
na?
no, no, see, what is that? If you are getting something from the anywhere, suppose that if you are getting the some network, see, we are
Okay,
router right now, I'm the router number 1. So this network and this network are directly connected. Which
okay.
network is not directly connected to me? That is the 30
R5,
network
R4, R6.
and 50 network, correct? And this network, if we have to send the something, so which interface we have to send? We have which interface?
Actually, that interface between R1 and R2 both are E00.
No, no,
That's
no.
why
For
I
this,
got.
see, this is outgoing interface. Check this outgoing
Yes, yes.
interface. So outgoing, that means if anyone's have to send something, this router have to send something. So which interface it will use for the sending
Yeah,
information to them? That is,
0
for
by
this
0.
network we use this outgoing interface.
But Jay, why it is not showing other information for E0102 like?
Why it is not showing? Because of these are directly connected. Guys, for the directly connected, you will see something. No, always you will get the something from the remote label. Give me a minute. Sorry. Yes, so that's the main thing. Come on, I have to get the call. Guys, am I audible?
Jay,
See
your
that,
voice
Yeah, yeah, yeah,
is
yeah.
Sayed, that
breaking.
No, no, no,
network
no.
20 and this 40 are directly connected to R1.
Yeah. Okay, my question was how it.
Let me tell you. So for here, uh, give me a minute. Hello, चच्चा पाला की मुबलिया मुबलिया हमें लगी नहीं चुमा रहे ना पापा का तो गाँव ही पुटना हो रही. Sorry guys, I got an important call, so sorry for that.
Okay. So first question was how it decides the label number, like 16, 17 it is used.
See, this is local label is always defined by the particular it is randomly choose any kind of label
Randomly.
number.
Okay.
Yes,
Okay.
if I
So
will
it could
just,
be.
it could be
So suppose it
anything.
is unique, then
Not for the unique. If it is decide only one label, so using that label it will send the all the information. But if that label has been decided yet, that hasn't decided yet, so it will decide it first of all, then it will share the labeled information to them. Okay, now let me just tell you one more thing. For the router number 1, What are the network are directly connected? 10 network,
10,
30,
20,
40,
not the
20,
30, not the 30.
20,
Come on, guys. Just count down.
10, 20, 40.
10, 20, 40.
Yes. Okay. This is what? This is local. Means you will not see that information inside the uh, forwarding table. So what are the others network which is we have? That is your 30 network and
450.
50 network. So you are getting this 30 network and 50 network using this interface. Got it? Means interface which is you have, that is this. Correct? You are getting this as a this.
Yeah, I'm surprised to see how it is collecting that information because we have not used any redistribution or any advertisement of the network. So
Yeah,
how it is getting that?
using the labels.
Strange. LDP protocol, LDP protocol.
Yes, the LDP protocol.
And you will configure the auto config command.
We have configured the auto config, but before the configuration of the auto config, we use the LDP. What we use?
Hmm.
LDP. So this is the
Right.
function of LDP, right? That is the work of
Whatever it is connected, it
MPLS.
will show.
That
Fine.
is the work of MPLS. Okay. Okay, guys. I'll just upload it on YouTube and you will get it. Okay.